Okay, we're going to look at perpendicular vectors. Okay, now a result that we know already is that A dot B is equal to 0 when vectors are perpendicular. Okay, that's something that we learned from our first look at scalar product. Okay, so let's look at solving a couple of problems associated with this. So let's look at example 1. Example 1, vector A is 3i plus 2j minus k. Vector B is I minus 4j minus 5k. Okay, and we need to show that they are perpendicular. Okay, so let's write them in column form. 3, 2, minus 1, 1 minus 4 minus 5. Okay, so A dot B equals 3 times 1 plus 2 times minus 4 plus minus 1 times minus 5. That's then 3 minus 8 plus 5, which is 0. A dot B equals 0, therefore vectors are perpendicular. Okay, that's that one. Okay, example 2. Example 2, vectors A, which is equal to 2i minus 5j plus k, and B, which is equal to pi minus 2j plus 4k are perpendicular. Find P. Okay, let's put them in component form. 2 minus 5, 1. And P minus 2, 4. Okay, so 2 times P plus minus 5 times minus 2 plus 1 times 4 is equal to 0. Now why do I know that? Because I'm told that the vectors are perpendicular. So I've got 2p plus 10 plus 4 equals 0. 2p plus 40 equals 0. 2p equals minus 14, p equals minus 14 over 2, and p equals minus 7. And the crucial thing is I knew that they were equal to 0, the dot product, the scalar product, because I'm told that the vectors are perpendicular, and the property of perpendicular vectors then is that A dot B is equal to 0. Okay, we're going to check and verify that the triangle with vertices A, which is 2 minus 3, 4, B, which is 5 minus 8, 13, and C, which is 405, is right angled. Okay, so let's sketch that out. Now it doesn't say exactly where it's right angled, so first of all I'm going to just test out B. Okay, so then it would be BA dot BC that I would be calculating. If that's equal to 0, then the right angle would be. I need to make sure that it's BA and BC because I need to have the vectors pointing away from the vertex. Okay, so BA then is A minus B. So that's 2 minus 3, 4 minus 5 minus 8, 13. And that's minus 3, 5, minus 9. Okay, so that would be BA. What about BC? Well, BC is C minus B. So that's 405 minus 5 minus 8, 13. That's minus 1, 8, minus 8. Okay, so let's now do the scale product. So minus 3 times minus 1 plus 5 times 8 plus minus 9 times minus 8. Okay, so that would give me 3 plus 40 plus 72. Okay, that is not equal to 0, therefore the right angle can't be at B. So let's try it again and see if it might be at A. So I'm going to sketch out again for A. So BC with A in the middle. So this time it would be AB dot AC. Okay, let's find AB. AB then is equal to B minus A, so that's 5 minus 8, 13, minus 2 minus 3, 4. So that's 5 minus 2 is 3, minus 8 minus 3 is minus 8 plus 3 is minus 5, and 13 minus 4 is 9. Okay, I'm now going to try AC. So AC is C minus A, so that's 405 minus 2 minus 3, 4. Okay, 4 minus 2 is 2, 0 minus minus 3 is 3, 5 minus 4 is 1. Okay, so let's try the scalar product this time. So it's going to be 3 times 2 is 6, plus, let's just write that out, 3 times 2 plus minus 5 times 3 plus 9 times 1. Okay, that's 6 minus 15 plus 9, which is equal to 0. Therefore, that must be perpendicular, so the right angle, therefore there is a right angle. So therefore right angle at A. Final answer.